and welcome to this NIOM webinar. I'm Håkon Valen, a dentist and a researcher here at NIOM. And today I have teamed up with a chemist and a researcher here at NIOM.
Yeah, hi, I'm Stenhagen. Welcome to this webinar.
All probably heard or read about adverse health or environmental effects after exposure to fluorine-containing compounds. And in this webinar, we will talk about the element fluorine. We will talk about where we find fluorine in different products.
And we will talk about the confusion that arises due to the fact that in the Scandinavian languages, all forms of fluorine are called fluor. So many different fluorinated compounds are found in products. We've brought a few here today. This Gore-Tex jacket. And fluorine is also found in the ski wax used on your cross-country skis.
And fluorine is also found in compounds used in frying pans. And important for this webinar, fluorine is also found in toothpastes. So, since we have a chemist here today, so Ida, what's so special about fluorine?
There's a lot that's very special about fluorine. So, fluorine is a very reactive element. It reacts with almost anything. And because of this, when it was first isolated by Henri Moissan in 1886, he then went on to receive the Nobel Prize for this in 1906. So, as I said, it's highly reactive and it wants to react with almost whatever it can come into contact with to form something new. And fluorine that you see in the periodic table exists as a diatomic gas. It's in group 17 of the periodic table, the halogens, and the bond between these two fluorine atoms is relatively weak, so it will break apart and react. And fluorine is also the most electronegative element in the periodic table, meaning that it will do anything, it will react to get a negative charge. And therefore, fluorine is found in a lot of different compounds.
One large group of man-made fluorinated compounds is called PFAS. So Ida, could you please explain to the audience what PFAS is?
Sure, Håkon. So PFAS is a group of nearly 5,000 compounds, and PFAS stands for poly or perfluoroalkyl substances. And here I have a model of one of the two PFAS compounds we know the most about, PFOA. And PFOA is a chain of 8 carbon atoms, these black balls you see here, and every carbon is fluorinated, so the white balls represent fluorine atoms. And then on one end we have a carboxyl group. The red are oxygen and the purple is a hydrogen atom.
But the form of fluorine found in our toothpaste is fundamentally different from these compounds.
Yes, Håkon. So in this structure we have carbon-fluorine bonds, which are of a covalent type, as we chemists call it. And here I've made a tiny little model of sodium fluoride, the type of fluorine that's most commonly found in toothpaste. So the green represents a sodium atom and sodium ion, and the white represents a fluoride ion, which are bound together in a salt form. And we here have an ionic bond, and in this structure we have covalent fluorine bonds. So these two are fundamentally different.
And to explain what is special about salt, we will show you here by using sodium chloride. If you, for example, take this into water, it will dissociate and give free sodium and chloride ions. Yeah. And if you do that with sodium fluoride, it will dissolve in water and give free sodium and fluoride ions.
Yeah, which is what we want in our toothpaste, right?
Yeah, but this is fundamentally different for the PFAS we discussed just earlier.
Yeah, that's absolutely true. So as I showed you with the models, we have here one sodium and one fluoride ion that can break apart. It's a salt, it's an ionic bond, so in water these will be floating around. But this will not happen when you add PFOA to water. The carbon-fluorine bonds will not break, so this is not a good source of fluoride. A lot of the confusion about fluorine comes from the fact that in Scandinavian languages such as Norwegian, Swedish and Danish, they use fluor or fluorine for all different types of fluorine compounds. But we've now spent this webinar trying to elucidate the differences between different fluorine compounds. And when it comes to toothpaste, we know that the most common form is sodium fluoride or another fluoride salt. But Håkon, as a dentist, what amount of toothpaste do you recommend for children, adults, infants?
From a small child, you can use a barely visible amount when the first tooth erupts. And you can do that by just dipping your toothbrush into the toothpaste. So you should only have a small but barely visible amount on your toothbrush from the first tooth erupts. Then, as the child gets older, we recommend that when the child is about 3 years of age, we recommend that you have a pea-sized amount of toothpaste on the toothbrush. Regarding the fluoride content, we recommend that children from 0 to 5 years of age use toothpaste containing 1,000 parts per million of fluoride. However, when your child is in the 5 to 6 years of age, they can increase the amount of toothpaste used on their brush. And in addition, we recommend that you use a toothpaste with the 1450 parts per million of fluoride.
Håkon, what is the rationale behind these recommendations?
So the basis for these recommendations regarding the amount of toothpaste you should use and the concentration of fluoride is that you want to provide a caries protective effect of fluoride and to minimize the risk for development of dental fluorosis.
In this webinar, we have explained that fluorine exists in many forms and can be found in many different products.
And we have also discussed that if you use the fluoride-containing toothpastes in the amount and in the concentrations as recommended, they are totally safe to use.
Please don't hesitate to contact us if you have any questions, and thank you so much for watching this webinar.